Welcome back to another explainer. Okay, let's dive right into this incredible moment in tech, because we are literally watching artificial intelligence evolve from just chatting with us to actually doing the heavy lifting. We're looking at a fundamental architectural shift here. I mean, think about it. A year or two ago, we were completely amazed when an AI could draft a quick email or, give us a decent dinner recipe. But the models we're unpacking today, they aren't just generating text anymore. They are executing long-horizon, fully autonomous workflows. They're transitioning from being helpful little assistants to highly capable digital employees. To really wrap our heads around the raw scale of what we're talking about, picture this. Imagine an engineering team tasked with migrating a 50 million-line Ruby codebase. In the traditional software world, that is a complete nightmare. Just think about the sheer logistics of that, the endless sprint planning meetings, the relentless bug fixing, the human fatigue of untangling 50 million lines of deeply nested, messy legacy code. It's a monumental task. Normally, you'd need a dedicated team grinding away for over 2 months of really grueling, error-prone manual labor just to scrape together a working prototype.
But here's the thing. We aren't just talking about theory anymore. Recent testing at Stripe proved that Anthropic's Claude F5 stepped in and successfully performed that massive codebase migration in a single day. 1 day instead of 2 months. This quote from Alex Wang perfectly hits the nail on the head. A 60x speed up in engineering time doesn't just save money, it fundamentally rewrites the economics of the entire software industry. It proves we are witnessing the awakening of an autonomous digital workforce that operates with just breathtaking speed.
So here is our roadmap for today. We're covering 1. The rise of agentic AI. 2. How GPT 5.6 Sol thinks. 3. Claude 5's adaptive mind. 4. The new safety guardrails. And 5. Recursive self-improvement by 2028.
Let's kick things off with Section 1, the rise of agentic AI and the 2026 landscape.
Right now, both OpenAI and Anthropic have brilliantly segmented their power. Instead of trying to build one massive model that does absolutely everything, they've built these very durable capability tiers. For OpenAI, you've got the GPT 5.6 family. Sol is the absolute flagship, Terra is your balanced everyday model, and Luna is built for high-volume, low-cost tasks. Then over in Anthropic's corner, they've introduced their top-tier Mythos class, which includes Fable 5. Now, what's absolutely crucial to understand here is why they do this. Both companies are strictly reserving their incredibly expensive, massive 1 million token context windows for those flagship models. And for any developers out there, you know a 1 million token window isn't just about reading a long book. It's about the model being able to hold an entire corporate code base, all the documentation, and a massive multi-step migration plan in its working memory all at the exact same time without dropping a single thread.
All right, moving to Section 2, how GPT 5.6 Sol thinks, and the coordinated team approach. Let's really look under the hood here.
So the mechanical engine driving this logic is where it gets super fascinating. OpenAI and Anthropic have taken completely divergent engineering philosophies to achieve enterprise-grade execution. Basically, Sol acts as a team of coordinated specialists, whereas Fable 5 operates like a singular, obsessive genius. OpenAI leans heavily on what they call parameter-driven parallel structures. In plain English, the model dynamically spawns different, isolated instances of itself. It literally clones its own thought process, gives each clone highly specific instructions, and tackles different pieces of a massive problem all at once.
By delegating tasks to these subagents, Sol literally divides and conquers. When you flip on Sol's Ultra mode, it spins up 4 distinct subagents right out of the gate, and it can scale all the way up to 16. Imagine the mechanics going on inside the system. One subagent is busy writing the code. A second one is instantly reviewing it for security flaws. A third is writing the unit tests. And a fourth is acting like a project manager, keeping everyone on track. They argue, they refine, they verify their individual components, and then they stitch it all back together. That internal brainstorming engine is exactly how Sol pushed its Terminal Bench 2.1 coding scores to a mind-blowing 91.9%.
But how does it physically execute that work while it's brainstorming? To eliminate all those wasted, slow round trips to an external server, Sol uses something called programmatic tool calling. It actually takes the massive step of running its own sandboxed code locally to find the answers. It writes JavaScript, executes it completely inside an isolated V8 runtime with absolutely zero network access, and processes all the intermediate results right then and there. This is a huge breakthrough. Executing locally means practically zero latency, and it's incredibly secure since your data isn't bouncing back and forth across the open internet. It allows the model to iterate on its own code thousands of times a minute until it finds the absolute perfect solution.
Okay, jumping to Section 3, Claude Fable 5's adaptive mind. Let's see how Anthropic built a totally different kind of brain.
Unlike Sol's whole multi-agent team approach, Fable 5 decides on a turn-by-turn basis whether it needs to initiate a deep thought block and exactly how long to dwell on the logic before it answers you. It just thinks, sometimes for minutes at a time. And here is a wild technical detail. If you try to pass a parameter telling the API to disable its thinking process, it will literally throw an immediate error. You cannot turn its brain off. For developers, this is a massive paradigm shift. We are officially moving away from those instant but shallow chatbot responses and entering an era of delayed but profound architectural solutions. Sure, you wait a little longer, but you get enterprise-ready architecture in return.
And the results of this continuous, always-on thinking are just staggering. Take the Pokémon Fire Red achievement. Fable 5 played the entire game from start to finish using only raw visual screenshots. No access to the internal game state, no hidden metadata. Mechanically, playing a game through pure vision requires immense spatial reasoning and temporal memory. The AI has to remember exactly where it was 3 screens ago, map out the entire world in its head, and plan its next move. It also autonomously designed a complete 3D printable CAD model and coded a fluid simulation perfectly synchronized to EDM music it composed using pure code, all without ever actually hearing the music. This level of spatial and visual mastery is exactly why Fable 5 is the go-to for deep, unassisted workflows.
Which brings us to Section 4, the new safety guardrails. We've talked about the engine, now we need to talk about the brakes.
Because these models can operate continuously, find zero-day software exploits, and architect massive systems entirely on their own, the stakes are incredibly high. So Anthropic created a fascinating 2-tier safety system. The raw underlying core model is actually called Mythos 5. It has 0 safety classifiers. It is incredibly dangerous because its autonomy means it could architect malicious code just as brilliantly as helpful code. Because of that, Mythos 5 is strictly locked down for vetted cybersecurity and infrastructure partners only. But for us, the general public, Anthropic took that exact same underlying intelligence and wrapped it in a remarkably strict, aggressive safety layer. And that packaged version is what we know as Claude Fable.
So, what actually happens if Fable 5's aggressive classifiers detect a dangerous prompt? Let's say someone asks it for a complex cyber exploit. Older safety models used to just print a generic refusal message and completely halt your workflow, which used to drive enterprise users absolutely crazy. Fable 5 doesn't do that. Instead, it triggers an automated fallback mechanism. It actively downgrades its own intelligence, handing the risky interaction off to the older, much less capable Opus 4.8 model. It's a brilliant engineering trick. It ensures strict safety compliance, but keeps the overall software pipeline moving forward without crashing the whole system.
All right, Section 5. We've explored the engine, we've checked the brakes. Now, what is the destination? Where is all this heading, and what is recursive self-improvement?
To see where we're going, we really just have to look at the math. If we track Anthropic's Epoch Capability Index, which is their way of measuring raw, unconstrained model power, the trajectory is practically vertical. Mythos 5 scored 161.29 on the AECI scale. Guys, this isn't just an incremental step up from last year. It represents a massive exponential jump in logical reasoning, pushing the frontier of AI capabilities way faster than even the top researchers expected.
And that brings us to a frankly stunning prediction. Based on this staggering progress and the fact that these models are right now writing, testing, and deploying production-level code in isolated runtimes, Anthropic co-founder Jack Clark predicts a 60% chance of recursive AI self-improvement by 2028. Mechanically, recursive self-improvement means the AI will soon use its own software engineering abilities to rewrite its foundational neural pathways. It optimizes its own code to make itself smarter, which then allows it to write even better code, creating a rapid, closed-loop feedback cycle, an intelligence explosion. We are potentially less than 2 years away from AI systems actively architecting their own upgrades.
So, let's pull all this together. We've gone from AI acting as a simple text assistant to a highly autonomous digital workforce capable of migrating 50 million lines of code in a single day, to systems that are on the absolute verge of becoming the architects of their own future. As we watch these models transition into engineering their own successors, we have to really think about what human engineering is going to look like tomorrow. When the AI is the one building the next AI, what exactly becomes our role in the loop? It's a fascinating and yet maybe slightly terrifying question to leave you with today. Thanks for joining me on this explainer, and I'll catch you in the next one.